Okay, class, today we're taking a look at Chapter 5 in the code book, which is identified as floors. And this particular chapter is actually relatively short. Um, Mostly what you'll be looking at is charts and information that define pre-engineered span and load-bearing requirements for floor joists. And the second part of the chapter discusses steel framing, and we're not going to discuss any of the steel framing requirements. Part of this class is focused on giving you the information required as it pertains to the Building Construction Technology Department, and right now at this point in time we don't really deal with any of the steel frame construction, and so I would encourage you to take a look, thumb through some of those pages. Steel is an interesting medium to be used for construction, but in this particular area or part of the country we don't see a lot of use for steel construction. Occasionally you'll see one, but not very often. With the prominent growth of timber that we have here and the readily available use of lumber, we pretty much stick to the wood components. Anyway, in a floor system, as you read through the chapter here, you're going to be able to learn more about what's required in a floor system, joist layout, spacing, different types of span ratings based on materials and grades of lumber. Also, different load requirements on a floor system, live loads, dead loads, different applications, whether it's a living area, bedroom area, storage area, attic area, etc. All of these things have different requirements based on the code that have to be designed or incorporated into a given set of plans. Also, with a floor system, you'll learn about what a girder is and how it's used to transfer loads and to bear other potential joists bearing on it, and then transferring those loads to outside points. A girder is usually a bigger member, usually a 4x type member, where a joist is going to usually be like a 2x member, 2x10, 2x12, something of that nature. This chapter is not going to be a real long chapter because a good portion of it is talking about the steel construction, but one of the things that you'll need to do is learn about how to read the charts, and it's not too terribly hard, but you have to correlate the information that's given, find the appropriate chart that is going to have that information, and then read the chart to find the actual answers that you're looking for. And so it might take a little bit. Make sure that you're really careful, covering all of the requirements as asked and finding the appropriate columns and rows that will have the information you're looking for. Also, one of the things that I want to talk about in the handout, though, there's one of the questions that asks you about allowable deflection, and a lot of students don't have a lot of engineering backgrounds, so just to cover this a little bit. Basically, deflection is anytime you have something that has a bearing point, from here to here, and it spans across. As you put load or weight on top of that, it's going to want to dip down, and that potential for any type of a movement is what we call deflection, and that deflection is allowable. Anytime you create a floor system with joists, it is going to have a certain weight or load bearing capability or capacity, but as you increase that load or decrease that load, you will have a certain amount of movement in the floor in that system, and so that's allowed for in the engineering. To get a really rigid floor where it's not actually going to move is quite impractical, and the little bit of deflection that we do see is quite minimal. But for the most part, the main reason for the allowable deflection as well, or another component to the deflection as well, is typically on an interior of the structure. If it's a two-story, you're going to have a second floor above, and the ceiling underneath is going to have drywall on it. And quite often that drywall, if you have too much deflection, potentially could cause it to crack. And so there are limitations that they allow for deflection and the condition that deflection is in. So anyway, deflection is just another component of the code. It's an engineering principle. It's allowable, but within a certain range or parameter. And typically the way they identify that is usually the length of the span over a predefined deflection allowed requirement. So anyway, you'll see that as you're reading through the chapter. Also, when you're going through the chapter here, you'll find that there's some figures that depict information as far as what's allowed as you, well, I guess it's not so much as the carpenter, the framer. Usually as a plumber, electrician, heating contractor comes along, typically they'll need to cut into some of the framing structure to either run their pipes, run their electrical or ductwork. And so in this chapter you'll learn about some of the information that's allowed as far as notching or cutting holes in different framing members, and what's the requirements and how that affects that structure. Now, for those of you that might have a little bit of engineering background, as you take a look at this information and understand the principle of load bearing and load transfer, it'll make a little bit of sense, hopefully, why there is a restriction to how much a member can be either drilled or cut and notched, because it's going to weaken that structural integrity in that member. So another component of this chapter, as you read through, take a look at. As I said, this is a pretty short chapter. There's not a lot of information here. And one of the things that I do want to point out, one of the questions asks you to calculate an allowable diameter hole. And I've found in the past with students, as they've taken a look at this question, they've used the nominal dimension of the member. And if you look closely at one of the figures, it specifies that when you calculate what an allowable diameter for a drilled hole might be, you use the actual, being that dimensional lumber has a nominal call out, but the actual size is usually something less than that nominal. So just be aware that when you answer that one particular question, that you're using the actual size and not the nominal. Okay, class, hope you have a good week, and we'll get back with you and see you here in a week. Thank you.